Okay, let's start question number 14. It's a little complicated, so make sure you listen very carefully, okay? So let's read the question first. Sides ABCD and median AD of a triangle ABC is respectively proportional to PQPR median of triangle PQR. So we need two triangles, ABC and PQR. So let's draw ABC. And let's draw PQR as well. Okay, A, B, C, P, Q, R. And then we have A, B, AC, AB, AC, and AD of a triangle, median AD. So we need the median also. Median means midpoint of BC is joined from the opposite vertex. So this is the median of BC. Okay. Here also PQ, PR, and PM, median PM. So we need PM, so midpoint of QR is M. Okay. So this is the question so far. The problem with this question is that they've given us, what they've given us is this. AB by PQ equal to AC by PR equal to AD by PM. That's what they've given us. Sides AB, AC, AD, AB, AC, AD are respectively proportional to PQ, PR, PM. So if you look here, AB, PQ, AB by PQ equal to AC by PR. Okay, up to here is fine. This by this equal this by this. Now they've given us the extra is AD by PM is also proportional. So if we look at these two only, if we look at only these two only, the triangle is ABC. So ABC, PQR. So AB by PQ equal to AC by PR. So in order to show that this, see, our goal, they're asking us, our goal is to show that ABC and PQR are similar. Okay, in order to show that, we need these two angles, angle A and angle P. If you look at these two, but the angles are not given, right, that it's equal. So we need to somehow prove that angle A and angle P is equal. See, I've had students ask me if they could have used SSS, three sides proportional. Okay, so we have AD and PM, and then D and M are just the midpoints of this and this. So there's no relationship between BC and AD, none whatsoever. Okay, no matter how much you try, you will not get any relationship between BC and AD, because in order to do SSS, this two is already done. So you need BC and QR. So somehow you have to replace AD by BC and PM by QR. And since there's no relationship between these two, there's no way to do SSS. So our only other possible way of doing it is SAS. Okay, AA out of the question, because they gave this, it has a purpose. I've already told you so many times, whenever they give you something in the question, it always serves their purpose. Okay, so we have to use either SSS or SAS. SSS is rejected because this and this, there's no way in relationship between those two, so we cannot bring or adjust somehow and then replace this with this. So the only other choice is SAS. So I'm going to do SAS. For this question, the hard part is the construction. Okay, so in case you don't understand or it doesn't come to your head how to construct, you can memorize it. Okay, just for this question, the construction part, not the whole entire answer, just the construction part, you can memorize it. Okay, so our construction is gonna be this. I'm gonna extend AD in such a way that I'll just draw a straight line. Okay, I'll extend AD in such a way that extend up to E, let's say, such a way that AD and DE are equal. Same here. I'll extend PM such a way that PM and let's give a name here, PQRS, let's say, and S is equal. That's our construction. That's right here, construction extend AD to E and PM to S such that AD equal to DE and PM equal to MS. Okay, after that we're going to do join BE, EC, QS and SR. So we're going to join all these points together, forming a quadrilateral. So I'm going to join this, okay, and then this QS and QR. That's it. So for the construction, you just remember that this is been stretched out, extended, and we join this equal to this equal to this, and then we join the other points. See, when it comes to geometry, okay, you can do whatever construction you need extra. I can make this into a very complex thing also, but one rule you have to remember is whatever they gave us in the starting should not be altered. Okay, this triangle, this by this proportional, it change. You can draw extra whatever you want. So what we're doing is we're going to draw this extension of this, and then we're going to join the points. Okay, now before we move on to this, let me tell you a concept which you should have studied in grade 9. So in case you don't remember, suppose this is a quadrilateral, any quadrilateral means four-sided figure, okay, and then I join the diagonals in such a way that this special quadrilateral, why is it special? Because the diagonals are bisecting each other. Bisecting each other means dividing each other into two equal parts. Suppose itu 20 like 10 10 is this 16 8 8, okay, basically like half. So if there is such a quadrilateral, by default this becomes a parallelogram. Got it? By default. Why? I'll show you why. Okay, just for your understanding, you don't have to do this, just to get the idea of why it becomes a parallelogram by default. Suppose you take this A, B, C, D and O. In triangle AOD and triangle BOC, you can see that AO equal to OC, this angle and this angle are vertically opposite angles. So AOD equal to angle BOC, and then you have OD equal to OB. So side angle side, by side angle side we can say AOD is proportional to triangle, or not proportional, concurrent to, right? And concurrent means what? Exactly the same, replica, which means this and this will be equal by CPCT, concurrent parts of corresponding triangles, right? So if these two is equal, similarly we can do exactly the same for AOB and DOC. So if we do that, this and this will be equal. We don't have any means to prove that this and this is equal, which gives us that one thing is for sure, that opposite sides are equal to each other, right? So if opposite sides are equal to each other, then it becomes a parallelogram. Any quadrilateral where opposite sides are equal to each other is a parallelogram. It is also a rectangle, but before you say it's a rectangle, it's always a parallelogram first. If the diagonals are also equal to each other, then it becomes a rectangle. But if you don't know about the diagonals, one thing is for sure, that it is a parallelogram whenever the opposite sides are equal. So which means if you have any quadrilateral where the diagonals are bisecting each other, then this quadrilateral automatically becomes a parallelogram. Got it? So now back to the answer. See, I've already told you D is the midpoint of BC. Literally means what? This and this is equal. M is the midpoint of QR, so this and this is equal. But in our construction, we say this and this is equal, this and this is equal, which makes what? This becomes a parallelogram, and this also becomes a parallelogram, right? So let's write what is given. Okay, join this is therefore let's continue from this. This is the contraction, and because of the contraction we can say therefore A, B, E, C and P, Q, S, R are parallelograms. Hence, since ABCD, ABEC, PQ are diagonals bisecting each other. Okay, diagonals bisect each other. Let's write that as the reason. These diagonals bisect each other in case you cannot read properly. So this and this are parallelogram. Why? Because diagonals bisect each other. So since this and this is parallelogram, I can say that AB, hence AB equal to EC and what? AC equal to BE. PQ equal to RS and what's this? PQ RS and then PR equal to QS. So this will be our equation 1. And then for reason, just write opposite sides of parallelogram are equal. Okay, now that that's done, let's write what is given. Okay, given in the question was AB by PQ equal to AC by PR equal to AD by PM. Okay, so here's the deal. Okay, I've already told you, in order to show that these two is similar, we need angle A and angle P, right? In this case, angle A is made up of 2 angles and angle P is made up of 2 angles. So firstly, I'm going to take this angle, okay, and then show that it is equal to this angle. After that, I'm going to take this angle and then show that it is equal to this angle. That way, if the red is equal, green is equal, literally means angle A is equal to angle P. So that's what we're trying to do. So in order to show that this angle and this angle, the red ones, is same, I need to take triangle ACE and PRS. Okay, I'm not gonna take ADC because ADC parisho agera napara construction kurishe. That's why we cannot take ADC. We have to take AEC triangle and PSR, and we'll try to prove that these two triangles are similar to each other, and since it's similar, red is equal. Okay, that's what we'll try to do. So I'll just keep this here so that we can look at it as a reference. Now, AB is equal to PQ, AC is equal to PR. So we are I'm taking triangle ACE. I'm looking at triangle ACE. Okay, so in ACE I can see that AC is here, which is this one, AC. So we don't have to do anything about this. PR is also here, so we don't have to do. So I need to do something about this and this, right? So AB here I just wrote AB equal to EC. So instead of AB, I'm gonna write EC by. Now instead of AB, I'm gonna write EC, and then instead of PQ, I'm gonna write RS equal to AC by PR equal to AD by PM from equation 1. Got it? Now I have to do something about this also. So let's do something about that also. RS equal to AC by PR. Now instead of AD, I'm gonna write half of AE. Got it? Because if AE, since we extended this in such a way that this and this is equal, if AE is 20 and this is 10, 10. So instead of AD 10, I can write 20 divided by 2. 20 divided by 2 is 10 only. So this, if this is full, this is half, this is half. So I can write AD as half of AE, right? So half of AE divided by PM, also I can write half of what? QPS. The reason is I can write AD is equal to DE and PM equal to MS. Okay. So now if I cut, if I cut this and this, we're left with EC by RS equal to AC by PR equal to AE by PS. Now if you look at the diagram, we have EC. EC is where? EC is this one. EC is this one. EC by RS, which is this one, right? Equal to AC, which is this, by PR, which is this, and then AE, the long one, by PS, the long one. So these two triangles is similar to each other. Therefore, triangle ACE is similar to triangle PRS by what property? SSS similarity. Right? Now, if these two is similar, what can we conclude? Hence, angle EAC is equal to angle SPR. Similar triangles property. Similar triangle property. Since these two are similar, all the angles will be same. Now we don't have to repeat the whole process again and again. Okay, so we can just write similarly. This is a shortcut of similarly. See, what we did was we wrote it and then we left AC by PR as it is. Now if we left AB by PQ as it is, and instead of AC, if I had put BE, which is, and then instead of PR, if I had put QS, it would have resulted in this triangle, right? AB by PQ, and because these two triangles are exactly the same. If you look at it, it's exactly the same, right? This and this, this and this. So if I did this, now if I do the exact same thing for this triangle also, I'll get it the same result. So instead of changing AB and PQ, now I just have to change AC and PR. So similarly, so I'm not going to do it, okay? And I don't think you will be required to do it also because the answer is already long. Similarly, in we can show that triangle ABE is similar to triangle PQS, and hence angle BAE will be equal to angle QPS. We have already taken one equation, so I'll take this equation 2, this is equation 3. Equation 2 plus 3 will give us what? Equation 2 plus 3 will give us angle EAC plus angle BAE equal to angle SPR plus angle QPS. The concept is, it might seem lengthy, but the concept is quite easy. The only difficult part is drawing this thing, construction part. So EAC plus EAC plus BAE is what? Or sorry, this BAE. EAC plus BAE is angle A. So this becomes angle BAC equal to angle QPR. But given what is given in the question, AB by PQ equal to AC by PR, which is given in AB by PQ equal to AC by PR. I'm just writing this so that we can see. We just showed that in these two triangles, we just showed that this and this is equal. So I'm writing what is given. This by this equal to this by this. So these two triangles will become similar. Therefore, triangle ABC is similar to triangle PQR by SAS similarity. Got it or not? See, I tried to make this as short as possible, so I hope you understood. So first write this, and then this. Now let's do question number 15. This one is very easy. A vertical pole of length 6 meter. Let's draw it. A vertical pole of length 6 meter cast a shadow of 4 meter long. So there is a pole 6 meter, cast a shadow of 4 meter long. So it's casting a shadow of 4 meter, and at the same time, same location, a tower cast tower, the tower, and the shadow it's casting is 28 meter. So let's say we just join these two, and let's say we're joining these two. Now the thing is, this is the shadow, okay, and this is the shadow, and then this is the pole, and this is the this thing, tower, okay. So if we give this names A, B, C and E, F, G, and this thing, whatever we're doing here, you can apply it in real life also, okay. So if you know the height and the shadow of a smaller object, and it's in the same, almost the same place, same time, then what happens is so what happens is the sunlight, since this thing place and the location is same, the angle with which the shadow is being casted, okay, will always be the same. This and this will always be equal, okay, since it's the same location and the same time, at the same time, and these two are very nearby. So the sunlight which cast the shadow, it will be at the same exact angle, these two, okay. We cannot see this, it's just this and the shadow, but the angle of the sun, inclination of the sun or elevation of the sun, will always be same, correct. So in triangle ABC and triangle EFG, angle B equal to angle F. Why is that? Because both are 90 degrees each. Why is it 90 degrees? Because these are altitudes, okay. There's a building or whatever power pole, it's always going to be 90 degrees straight na kun tera bane tower na. So 90 degree. Angle C equal to angle G. You can write angle of elevation of sun, angle of elevation of sun, okay. Therefore triangle ABC is similar to triangle EFG by what? AA similarity. Now therefore we can say AB by BC equal to EF by FG. What is AB? AB is 6, BC is 4. Oh sorry, this by this equal to this by this, na? AB by EF equal to BC by FG. It's always gonna be this one side of this triangle and the other side of this triangle, okay, not this by this, this by this. It's always gonna be this by this, this by this. So AB, we have AB is 6, EF we don't know, BC is 4, FG is 28. So we can cut 6 ones are 6, 7, 4 ones are 4 sevens are 28. So if we cross multiply, this 7 will come up, EF will go up, will multiply each other. So 6 into 7 equal to EF, or EF equal to 7 6 are 42 meter. Okay, so that's it for this exercise. For the periodic test, only up to this exercise will come. As I've already told you, this is a concept which you can even use in real life. So that's what it is.